Hello everyone, welcome back to Cambridge AS and A-Level Biology with Dr. Demi. I feel like we need to change that name to something that's maybe shorter and easier for people to remember. But for now, welcome back. I know it has been a really long time since I did a video recording. And for some of you, I've been getting some very anxious comments. Oh, Dr. Demi, where are you? What are you doing? Well, I don't want to give out too much detail, but I am busy with a transition at the moment. But I just thought to myself that the May-June exams are really close. And I know majority of the students write in May-June because you want to get into university for September. So I have decided to try to do a couple of videos for you, just again to help you prepare. And to improve your chances of success. So just again want to say congratulations to those who passed their AS level exams with A's. I am very proud of you. Those who got B's and C's, also very proud. Even if you got a D, very proud, because I know that it takes a lot of work to get through the biology exam. And many people have this misconception that biology is the easiest subject for A levels, and that is not the case, because once you get into it, you realize that it is a lot of work and it requires a lot of thinking as well. So I am going to do a paper 5 question paper today, mostly because one of my former students requested it on my most recent shorts video and said, can you please do more paper 5 questions? And I know from my experience as a teacher that quite a number of students struggle with paper 5, especially when you encounter it for the first time. So since there aren't any question papers for the past 2 years, I think for 2020 and 2021 sort of, it means that we will have to go all the way back to 2019, but the principles remain the same. So just to start you off, I want you to know that paper 5 is a planning and analysis paper, which means that when you go into the exam to write this paper, you are not expected to do an experiment at all. What you are expected to do, however, is to plan an experiment. And what I often say to the students that I have taught this particular section of the A-level syllabus is that you need to imagine yourself in the position of a person doing the experiment so that you can think of how you would plan it out. And you need to be as logical and as analytical as possible for you to pass paper 5. For this video, I have only chosen the first question of the paper because that is the one many students struggle with. So we're going to look at that, and obviously you can leave comments. If you don't understand, you can watch the video over and over again. But what I would recommend is just before you watch the video, grab a pen and paper. And try to just take notes as we go along, and perhaps try to solve or answer the question yourself. Obviously, I might not pause as long as you need for you to be able to do that, but I recommend it because it does help you with your thinking through this paper as well. So let's get into it. Okay, so I've turned my video on for this one because I just feel like it might add a bit of flair to how you perceive the explanations. Again, if it becomes distracting, by all means let me know. I am very comfortable shooting without my face like I did with most of the videos. I think there are 89 videos, but let's see how this one goes. Please don't be distracted by my hand gestures. I tend to gesture a lot, but let's get into the question. So it says here, some students wanted to determine the reaction time of a sample of people aged from 5 to 80 years. Reaction time means the amount of time it takes for a person to respond to a stimulus. So you might have noticed when you're playing with your friends that if you jump out at some of them, they're immediately shocked, while for some of them, they might just stand still and not move, while for some of them, they might stand still for a few seconds and then they go, ah! Those are varying reaction times, okay? So a reaction time is the amount of time it takes for something to change or to happen. The students found 3 different methods of testing reaction time as described in figure 1.1. So method 1 is the ruler test. In the ruler test, the subject, that's the person that's being tested, rests their elbow on a table so that their wrist extends over the side. So if you imagine that you had a table here, the wrist would be extending over the side. Okay, so I hope you can see that clearly, but I hope you get that. So their wrist extends over the side. The assessor holds the ruler vertically in the air. So I don't have a ruler here, but I do have a pen. So the assessor is holding the pen like this. And you see that the assessor is holding the pen between the thumb and the first finger of the subject. So it means it's going, this is your thumb, for those of you who might not be aware. This is your first finger, so the ruler is sitting somewhere there. The 0 mark on the ruler is lined up with the first finger of the subject, and the ruler is released without warning. So basically the ruler is dropped in there. All right. As soon as the subject sees the ruler fall, they catch it as quickly as possible, and the distance the ruler falls is recorded in meters. So that's method 1. Method 2, it's a computer click timer. The subject looks at a computer screen and clicks a start button on the screen and waits for the background color to change. As soon as the background color changes, the subject clicks a stop button on the screen. Okay, and the reaction time in seconds appears on the screen. I am working from 2 different screens here, so if you see me turning around, that's the reason for that. So that's method 2. So there's a computer screen. The computer screen has a particular color, and the subject goes there, clicks start, and the color just stays the same for a period of time. But as soon as the color changes, the subject has to click stop, and that basically then measures the time between when the change happened and when the subject clicked stop. So that would be the reaction time there. Then there's a third one, which is a light board test. The subject stands in front of a board with buttons arranged in a pattern. The buttons light up randomly. As soon as a button lights up, the subject presses the button to turn it off. As soon as a button is pressed, another button lights up, and the number of lights turned off in a set time is recorded. So it's more or less just like trying as much as possible to switch off as many lights as you can. Let's look at what the questions are here. The students decided that method 2 was the most suitable to use for testing subjects aged from 5 to 80 years. Why is method 2 the most suitable? Now, again, you can see here there are 2 marks that have been allocated, which basically means you only need to write 2 reasons. And I always say this to students, that because paper 5 can be ambiguous for some students sometimes, they tend to want to fill up the whole thing, and they end up writing a lot of stuff that doesn't even pertain to the actual answer. So in this case, why is method 2 the most suitable? I'm just going to give you like a couple of seconds to think about that. If you were doing this test, again, remember this is about role playing, would you use method 1? Would you prefer to use method 2? Would you prefer method 3? And why would you use any of those based on what you choose? Okay, so I'm just going to tell you. So first of all, method 2 is a lot easier because it just requires, irrespective of the age of the participant, that they sit in front of a computer, wait for a screen color to change, and then just click stop. That's all it requires. Method 1, the reason why I wouldn't pick method 1 as a suitable one, so I'm just going to give you some background information, is that you might be dealing with some age-related issues here that would make your results not consistent. So for example, there might be an 80-year-old person who's very agile, very fast, and is able to grab a pencil quicker or a ruler quicker than a 5-year-old would, all right? Similarly, you might also have an 80-year-old who is just not able to grab because they are a lot older. And that applies to people across the age spectrum in this experiment. So that would make method 1 an unsuitable method for you to use, or maybe not the most suitable one. Method 3 also requires some form of agility, it requires, so that might also be affected by age, and you're trying as much as possible not to make it so, because you're not testing age, you're trying to measure reaction time. So in this case, 2 reasons why method 2 would be the most suitable would be because, first of all, it's very easy to explain to the participants. It doesn't require any form of physical agility in how they respond per se, because it's just sitting there, like I've got my mouse here, and all they have to do is just press click, okay? And then that's it, and it's done. So for those two reasons, number one being that it's very easy to explain. Number two, it doesn't require any physical agility that might impact the test results given the age bracket that you're measuring. That makes it most suitable. And your results will also be precise because the subjects simply have to sit and make one movement. All right. They only have to make one movement. They don't have to make a lot, or they don't have to be freaked out when you drop a pencil like, oh, where did it go? So for that reason, it's a much more precise result. So you can use that to explain why method 2 is the most suitable method. The second question, and you always get this in paper 5, just by the way, it says, what is the independent and the dependent variable? The dependent variable, the best way I can explain it to you, is the one that you are measuring. Okay, if you're not sure of what these two are, the dependent variable is the one you're measuring. The independent variable is the one that might be impacting the dependent variable. So in the case of this experiment, we have age, all right, as an independent variable, because you're not measuring the age of these people. They came in and they said, I'm 5 years old, or I'm 16, or I'm 28. And so that's something that's already a given. What you are measuring is how long does it take a 5-year-old, a 16-year-old, a 28-year-old, a 79-year-old to respond to a change, to a stimulus or to a change on a screen in this case. So your dependent variable then would be reaction time, because that is what you are measuring. The second question here says, describe how the students could investigate the reaction time of a sample of people aged from 5 to 80 years old using method 2. Now, in this question, students might be tempted, and I promise you this happens a lot, that they would say to themselves, well, the method has already been given, so I just need to rewrite the method. But if you look at the question a bit more carefully, it says your description should be set out in a logical order and be detailed enough to let another person follow it. I mean, that makes sense. Again, if you were to follow my advice, where I say you have to play the role of the experimenter. You're the one doing the experiment. Obviously, you will think logically about how this experiment would go, so that way you would outline logically as well. But something else that comes out in this question is that it says details of method 2 as described on page 2 are not required. So you can't go back and say, I would set up a computer and I would do this, and then they have to click something. You can't do that in this question. So this requires you to then think outside of what method 2 has detailed for you. What are the factors that would influence this experiment? So I know this is not a live class, but again, if you have your pen and your paper with you, I will be silent for about 10 seconds and just think, what are the factors that would come out? And just maybe write one word for each factor, and then I would pick it up in 10 seconds. I just want to give you some time to think about it and figure out what you would consider if you were planning this experiment. Okay, so that's probably 10 seconds gone. Let me go into it. So the first thing you have to consider is the distribution of the ages, right? So you have, and the number of people that you want to test. So you can't say, I'm going to test all the people between the ages of 5 and 80 in the city of Johannesburg or in the city of Nairobi, for example, because that would just take you forever. So you have to limit it to what we would call a statistically representative sample. And you don't have to say it that way, but you can say, well, I would choose a sample of maybe 1,000 people. Now, if you're choosing 1,000 people, something else that comes into play might be you want to separate them based on their sex. Are they male or are they female? And you might want to have an equal distribution of that. So I want 500 females and 500 males. And again, the number doesn't have to be this large. You can just maybe say you want to test 50 people or 100 people. That's also fine. The point is you just have to make reference to a specific number that binds, your experiments. You can't say I would just test people. How many of them? How many of them would be male or female? Because then the results might differ. It might give you some insight into how males behave compared to females. And I'm sorry if this doesn't satisfy the what's it called, the expanded view of sexes as we know them now. But in biology, most of the time, the restrictions, especially for A-level exams, are usually either male or female. So just putting that out there. So you'd want to specify an equal distribution between those two. You would also want to specify an equal spread in the categories of age. All right. So in this case, for example, you have ages 5 to 80. You want to have the same number of people in each age bracket. So maybe if you say 5 to 10 is an age bracket, then the same number of people should be there. From 11 to 15, same number of people. So you can just say, first of all, specify the number of people, equal number of males and females. Then you want to say specifying the distributions for the age brackets, ensure that they are the same number of people in each age bracket. Then the other thing that you want to specify, which is something that you might not have thought of, is you want the conditions of the experiment to be constant for every person, which means that you have to use the same type of computer. You have to use the same type of mouse if you're going to be using a mouse for them to click on. Everything that is required for the experiment itself must be the same. So I'm just going to use my pen here just to write this down, because I know that students struggle a bit with this. Obviously not going to write things out in detail, but I'm just going to say here number of people. Okay. Then you also have distribution in age, equal distribution, that is. Okay. And this is a 6-mark question, so you only have to write 6 things. All right. Distribution of age categories. I'm not going to write categories, I'm just going to write it as cat. You also want distribution of gender. Okay. Then you want to ensure that conditions of experiment are constant, constant experimental conditions. And again, you might not write this out the way I am doing right now. You might want to make it a little bit more of a detailed explanation. But even in being detailed, try as much as possible to be succinct, which means just to make your thing as short as you can and as direct as possible. So constant experimental conditions over here. Something else that you want to do, if you're testing reaction time using method 2, what else is important? What does method 2 require them to do? It requires them to look at a screen and wait for the color to change. And when the color changes, they must click something that then measures how long it took between the color change and when they clicked to measure their reaction time. If a person is color blind, they might not see the change. So you want to ensure that when you select your sample, you remove people who might be affected by things like color blindness. All right. So if a person's colorblind, they would be considered an unsuitable subject for such an experiment because they might not notice the change. So you might say, oh, it changes to green. So when it changes to green, click the screen. And maybe when it changes to green, they are seeing red instead, and they're like, oh, this is not green. And so that then creates a problem in your experiment. So you would not want to use people who have that. You also don't want to use people who have, for example, drug use, okay, or people who take coffee, people who have had caffeine. So you then have to say exclude individuals who have conditions that might make them inappropriate subjects. And you can then mention the examples, e.g. color blindness, e.g. caffeine takers, because people who take caffeine might be really jumpy, and so even maybe before the color changes, they've already clicked, or even after it's changed, like it might just impact how they react to the experiment. So you also want to exclude those people. Something else that is very helpful that I always say in the method question will at least get you 1 mark is to always emphasize repetition. When you run an experiment, you want to repeat it
maybe a minimum of 3 times, okay, and then get the mean values. By including that, sometimes, especially if it's an experiment that requires measurement, you are likely to already have one mark down. If you are dealing with chemicals in your experiment, then you want to mention that people should wear protective equipment. But in this case, you're not dealing with any chemicals, so there's no need for that. So your number 6 would just be to repeat the experiment 6 times, not 6 times, repeat 3 times per person and take the mean value. All right, so repeat and average the mean value per person so that you can have a more statistically significant set of results, or not statistically significant, statistically reliable set of results that you can fall back on. So that is the method question, and I know this is where many students struggle, so I've spent quite a lot of time on this one, but let's press on. All right, so here it says the students found some results on the internet for a reaction time test as shown in figure 1.2. The error bars show plus or minus 1 standard deviation. So if you haven't reached this part where you're dealing with standard deviation in your syllabus, it is somewhere around from chapter 17 to chapter 18, between those 2 chapters. So please, by all means, go and have a look about how it's calculated and what it means. But basically, a standard deviation is a deviation from the average, okay? So by how much is a value deviating from the average that has been measured? And you can only get a standard deviation if you have done your sample size very well, and if you have your error bars here, they also just show, these are what they show. So they show the upper and the lower limits for the standard deviation. So let's have a look here. It says the percentage change in mean reaction for males between the ages of 5 years and 10 years is 47%. Okay, and we can just look here. So this is age in years, this is mean reaction time. So if this is 10, you can just count the graph boxes. Please don't be lazy about this because you don't want to make an error. Okay, if you look at it here for males, males are the darker ones over here. So you can just trace that line all the way there. And if this is 100 and that's 200, I believe this is about 20 boxes between them. You can count that. Is it 20 or 10? I think it should be 10. Because that then tells you what the value of each box is. So by all means, make sure you check that. So I think I just check quickly. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it is 10. So it means that between 100 and 200, there are 10 boxes. So each box is like 110, 120, 130, and it goes on like that. So if this is the male at 10 years old, this is sitting at 180, I believe. Okay. And so you can then check the one for the male at 5 years old in order to determine how they got 47%. But that's not what the question is asking us. I'm just using that to demonstrate to you how you would approach this. Then it says here, calculate the percentage change in mean reaction time for females between the ages of 5 years and 10 years. Show your working and give your answer to the nearest whole number. Whenever they say give your answer to the nearest whole number, it means that you need to take out the decimal points. All right, this question is 2 marks. I didn't show the snip on the snip rather on the image, but it's 2 marks. So it means you get 1 mark for your calculation for showing how you calculated it, and you get another mark for your your final answer. So if, for example, the answer is 10.5, okay, and they say here to the nearest whole number, if you write 10.5, you are going to lose that mark. The nearest whole number for 10.5 is 11. All right, so you want to make sure that you are getting it right to the nearest whole number as prescribed rather, or as requested by the question. In some cases, they might say to 2 decimal places. So my point is just always read the question to be sure of what the answer is asking you to do. So let us do our calculation here for females. So we know that the females are the light ones. I'm just going to erase all these marks I've made so that it's just a lot easier for you to see. So now let's go back here. So the females are the light ones, and we're dealing with females between the ages of 5, which is over here, and the age of 10, which is over there. So now let's look at it. If we look very closely, and you can see that I'm trying to do that, I'm not sure if my glasses actually allows you to see, but if we look closely, for females at the age of 10, the value is about 210. All right, so I'm writing here on the blue part of the screen. Please just look there if you can't see it. That's 210. And for females at the age of 5, those are the younger females, the value is about, let's see, this is 310, 320, 330, 340, if you were to trace it down there. So that is 340. Okay. Now, when you are calculating percentage change, always remember you're going to take this value here, the initial value, all right, that's 340 minus the final value, because you're taking the value that's coming after, right? So you can do it that way, divided by the initial value, and you multiply that by 100. Okay, so thankfully in your A-level exams you are allowed to use a calculator, so please don't go to the exam without one, and don't try to do the math off by heart, even if you are amazing at math, because you will be surprised at the kinds of errors that you are likely to make. So the answer that I have gotten, I don't know if you can see it, is 38.2%. All right, so 38.2%. Now, if you were to round this off mathematically, it would be 38. That means for your final answer, you simply write 38%. And another thing is that in the question, if the section where you're supposed to write the answer doesn't have the unit, please make sure you include the unit, because if you fail to do that, you might also lose marks. Okay, so make sure to include the unit if it's not already included. I think for this particular question it was included, so you should be fine here, but if it's not, make sure you write it down. If the answer was 38.5, so this is just an example, if it was 38.5, then you would be rounding off based on what the question has asked to the nearest whole number of 39. But in this case, 0.2 doesn't allow us to do that. So I hope that's clear. Yeah. Okay, let's move on now to the next section. It says, state 2 conclusions about the trends shown by the results in figure 1.2. When you look at figure 1.2, and I've put it here so that you can refer to it again, I'm just going to give you a few seconds to just look at it. And again, me saying I'm giving you a few seconds is not an indication of what you will have in the exam. As a matter of fact, for this paper, I believe you have an hour and 15 minutes for 2 questions. But as you might see, it requires a lot of thinking, because for just one question, this video is almost 30 minutes long already. I'm just explaining it. So do take your time, don't feel too pressured. But when you look at this graph, what do you see? First of all, you can look at the indicators, or the legend rather. So here it's male and the lighter one is female. So the males here seem to be at the bottom compared to the females. All right, can you see that? So your first conclusion can be that reaction time, which is your dependent variable. Oh, and that reminds me, something else I must tell you is that the dependent variable is the y variable, so it's always plotted on the y-axis, while the independent variable is always on the x-axis. All right, so just have that at the back of your mind in case you're struggling with the interpretation. So in this case, the mean reaction time, which is the y variable, is higher in females, because when you look at this, you can see that the lighter indicators or lighter markers are at the top, while the darker ones are at the bottom over there. All right, so mean reaction time in females is higher at most ages. For most of the ages, it's actually only the same at the age of 5, it seems, and maybe at the age of 80 it's almost the same. But for most ages, and also at 70, but for most ages, mean reaction time is high in females. The second thing that you might want to also just bear in mind is that when you look at the error bars, so remember those error bars, because when you had the indicators, just look here on the side, the bars, the markers look something like this. So this is what the error bar is, and it basically shows the standard deviation. So whenever you see an overlap between the error bars, what that tells you is that the difference between the data sets that you might be dealing with is not statistically significant. It means that there isn't actually a major difference between them. So that you might say, yes, females are higher, right, if you're looking at the absolute raw figures, but if you were testing it in terms of statistical significance, then you can say there is no statistical difference between the males and the females. So I'm just going to write here, no statistical difference, and you have to explain why you say so. So you can't just come up and say there's no statistical. No, you have to say there seems to be no statistical difference because of an overlap of the what's it called now, of the error bars. And here female reaction time is higher, so I'm just going to write female higher like that. And that reminds me, please don't do this in the exam. I had students who, if they wanted to tell me something is increasing, instead of writing increasing, they would draw me an arrow and then proceed to shade the inside of the arrow. So whatever time they saved from writing out increasing was spent shading an arrow that I did not ask for. Please don't do that in the exam and expect that your examiner would be able to interpret what you have come up with. Something else that you can refer to in this graph, if you were to pay close attention, is that you can see the reaction time starts really high. So you can look at the overall trend of the graph. Reaction time starts really high, and then for some reason, after the age of 5, reaction time decreases and then slowly increases again after a certain age. So you can also make reference to that as a conclusion that you can see in the graph. Always remember, whenever you are asked to draw conclusions, you simply, if it doesn't say explain the conclusions, it says state. What you need to do is just look at what you have been provided with, okay, and draw conclusions based on that, because it hasn't asked you to explain, so you don't need to draw on any knowledge outside of the image you've been given or the graph or whatever it is. If you're asked to explain, then you will want to draw on what is on the graph and then use your background knowledge of biology to explain it. So that is how you would approach that. All right, let's go to the last slide. Oh, I love this one. It says, state a suitable statistical test the students could use to find out if the difference in reaction times between males and females of the same age was significant. Give a reason for your answer. So in this case, they're saying we're going to have two categories. We will have category 1, which is male, and we will have category 2, which is female. And we want to check if the difference in reaction time between males and females of the same age is significant. In this case, you might be thinking, and I've heard students think this way, and by the way, I don't put down any line of thinking. By all means, the creativity in thinking is what makes it worthwhile, because you can stumble on interesting ideas by doing that. But you can't say, I will take male number 1, test him, and then take male number 2 and test her, and just keep doing that, because then that might create problems for you. There is a statistical test you can use to check the difference in mean values, and that test is called the t-test. If you haven't done anything on the t-test, I have a video on the t-test on this channel, so please make sure you have a look at that, okay? So why would you use the t-test? You can use it to check the difference between mean values, so that would be a reason. The data is also continuous. So when we say data is continuous, it means you have numbers, right? A range of numbers that you can use. Categorical data is data that is not continuous. So something that is categorical, for example, might be eye color, right? So you either have blue eyes, or you have brown eyes, or you have green eyes. There is no continuity between that. So that would be a categorical variable. Just thought to explain that. Then they say, suggest a null hypothesis for the test that you have chosen in 3. And if you've watched my videos on the t-test and all the other tests that you have to do in biology, you will remember that the null hypothesis is always that there is no significant difference between whatever things you are measuring. So in this case, you would say there is no significant difference in the reaction times between males and females of the same age. And with that, you get your mark. that was one question of paper 5, and I know for some of you that was just like, oh my goodness, what was this? But again, just watch it over again. I think I have a couple other videos on paper 5, but this was just to help you understand the process of thinking about it. The thing with paper 5 is that you can't memorize how to answer the question. It's not the same as the theory of biology or even the practical aspect of biology. It requires you to think deeply, to design an experiment, and to think of all the factors that might impact that experiment. So it's not exactly the easiest, I'll admit, for students who are who have quite a heavy biology load, but it is not an impossible paper to get full marks in. So I always say this is one of the papers where you can actually get 30 full marks if you answer them correctly and if you think deeply about how you're answering the question. So I will leave it here, and I hope that this video is helpful. I do not know when I will record the next video, but I just saw a cry for help from one of my former students and thought to do this one in the middle of a very busy day. So I hope you enjoy it, and I hope that you are studying well ahead of your exams. I wish you guys all the best. Good luck and goodbye.